Inductive effect. Inductive effect, it is the one of the category of the permanent effect and polarization effect. Here I have the written polarization effect. It is called inductive effect. Electronic effect. Electronic displacement is classified into polarization effect, polarizability effect, and this polarization effect is called, the first category is called inductive effect, then mesomeric effect and hyperconjugations. We are reading the inductive effect. To understand in detail about the inductive effect, first of all I want to make clear that in some basic concept before we proceed about the inductive effect. A covalent bond is formed on account of equal contribution of the electron by the two atoms. This is the covalent bond is formed by this ethane. This carbon this bond is the covalent bond. This is formed by the equal contribution of the electron by the two atoms. This is carbon there is equal contribution by these two atoms, and the covalent bond are formed. Here in the chlorine equal contribution covalent bond are formed. Here is the hydrogen H2 molecule, their equal contribution covalent bond are formed. This is the equal contribution will occur covalent bond form if the two atoms are same. This is the carbon, this is a carbon, but one will be fluorine, one will be hydrogens. If the two dissimilar atoms will there then there will be not equal contribution, not this electron will not occupy the middle position. Now this is the two atoms are same, so covalent bond are formed, two electrons occupy the middle positions. But if two will be dissimilar atoms, one will be more electronegative, less electronegatives, means there is a difference in the electronegativity, then that condition the two atoms will not occupy the middle position. It will slightly shift more shift, means it will shift towards the more electronegative atoms. Here I have written this the definition. In case of two atoms are similar, the electron pair occupies central positions between the two nuclei of atoms. Such a bond is known as non-polar covalent bond, and these are the examples. Such a non-polar covalent bonds means two atoms are similar, the covalent bonds are formed, electrons occupying the middle positions, so they are calling non-polar covalent bonds. Non-polar bonds, as the influence of electron pair is same on the both atoms. In covalent bonds between two dissimilar atoms having different electronegativity, the electron pair doesn't remain in the center but is attracted towards the more electronegative atoms. I have already said that it will slightly shift toward the more electronegative atoms. The bond becomes somewhat polar due to unequal sharing of electron pair. For example, this is the two atoms. Here this is the covalent bonds are formed, carbon and halogens. Halogen is the more electronegativity, so it will attract more and more electrons clouds. Here I am showing this is a middle, but this is electrons cloud, so it will more attract the electrons clouds towards the halogens. It will more shift towards the halogens because halogen is the more electronegative than the carbon. So it will acquire a negative charge, it will acquire a positive charge because it will have less electrons. This will halogen will have more electrons. More electrons means they will acquire a negative charge, showing that they have a more electrons. They are electron rich because they are electronegativity. Actually, more electronegativity, they will attract more electrons, they will shifting more electrons towards their atom sides. More electronic atoms, the atoms cloud shift towards these atoms, so so they have a more electrons, so they are showing minus charge. A carbon has a less electronicity, so they are showing plus charge. Del means smaller we are showing by del. So this is in the middle positions, this is in the middle positions, and but it will look like this, but it will not in this situation, as this will acquire negative charge, this will acquire a positive charge because halogen is a more electronegative, so del minus. Carbon is less electronegative than the halogens, so it's showing del. Here this is the Now this is in this form, yeah, you can say halogen is more electronegative, so it will draw more electrons towards this. So it is showing this cap on a bond, and the arrow on a middle position of a covalent bonds. This arrow, uh, this arrow is has shown. This arrow is shown. This is the negative charge. This is a positive charge. In this way, we can denote that polar covalent bonds. And next, further we will understand more. The polarity thus has produced in a molecule as a result of higher electronegativity of a one atom compared to another is termed as inductive effects. Inductive effects means polarity in the produced in the molecule because if one atom has a higher electronegativity. One atom has a higher electronegativity. One atom have a higher electronegativity. This is a chlorine has a higher electronegativity than the carbon. Then this produce a polar covalent bonds. Bonds are polarized. So we are calling polar covalent bonds. The polarity thus produced in a molecule as a result of higher electronegative atoms of one atoms compared to another is termed as inductive effect. And that inductive effect, in this way we can give the examples of inductive effects. It is important to note that electrons pair, although permanently displaced or simply shifted, but remain in the same valency shell. Here the electrons shifted towards the chlorine atoms, but from the carbon it is shifted, means slightly shifted towards the chlorine, but it will not leave the valence shell. Carbon has a valence shell, chlorine also has a valence shell, and covalent bond is formed by the sharing of these two atoms. And by the more electronegativity of chlorine, electrons are shifted towards the chlorine, but it will not leave the valence shell of carbon. The atom which is in the valence shell of carbon, it will remain in the valence shell of carbon, but it is shifted towards the chlorine, but remain in the same valence shell. So the point of this is that but remain in the same valence shell. The inductive effect always transmitted along a chain of carbon atoms. Means this is a chain. This is a chain. The inductive effect transmitted along these chains. Means sigma chains are involved in the transmission of inductive effects. Note the pi's. If there will be in the pi bonds, if there will be in the pi bonds, then only sigma bonds will be participate in the transmission of inductive effect. Note the pi bonds. Only sigma bonds will participate in the transmission of inductive effect. Note the pi bond. Whenever the electrons withdrawing groups such as halogens group NO2 cyanide carboxylic acid is attached to the end of carbon chain, the sigma bonds electron of CX bond are slightly displaced towards the more electronegative halogen atoms. And the meaning of the sentence is that chlorine atoms, any electronegative atoms are attached, then electrons will shift towards the more electronegative atoms, and it will acquire a del negative charge because it is more electronegative than this carbon atoms. And the inductive effect is the distance dependent effect, means its effect will be negligible more than 4 carbon atoms. Here is the 4 carbon atoms, 1 2 3 4. Chlorine will attract more and more electrons of C1 and C2 C3, but it will attract more electron of C1, and it will attract C2 but less than C1. It will attract C2 electrons and it will attract C3 electrons but less than C2 electrons, means it is in the decreasing order. Here it is in the decreasing order. The electronegativity of more electrons will attract C1, then to C2, then C3, and C1. So del plus showing more electrons will attract C1, and double del plus triple del plus means it will attract less and less electrons of C3. But after C3 it will negligible for C4, means it will not attract C4 electrons. It is negligible after C3, means C carbon only will affect by the inductive effect. This the inductive effect produced by this chlorine atoms will affect only 3 carbon atoms. More than 3 carbon atoms, it is negligible. So these things I have shown in only 3 carbon atoms. In this way we are denoting that C1 attracts more and C2 attracts less, C3 will attracts less than C2, means C3 will attracts very less, and C4 will not attract. So C4 has no any del plus charges. Due to more electronegativity of chlorine atoms, Cl bond will pair slightly displaced toward the chlorine atoms, hence creating partially negative charge over chlorine atom and partially positive charge over C1 atoms. Means this has a partially positive charge, partially negative charge. All these things, whatever I have explained, all these things are written. Here I have also written the electrons never leave their original atomic orbital. Means it will attract the C1 electrons. Chlorine will attract C1 electrons, but it will C1 will not lose his electrons from its valence shell. The electrons remain in the valence shell, but only shifted towards the chlorine atoms. Only meaning is that the inductive phase always operated through sigma bonds. I already told only sigma bond does not involve in the pi bond electrons. The electrons will attracted, shifted. The inductive effects operated only in the sigma bond electrons. It will not involve the pi bond electrons. This type of electron displacement along a chain due to presence of source is called inductive effects and transmission effect. Means inductive effects can also be called as a transmission effect. The inductive effect is denoted by the arrowhead in the middle of covalent bond pointing in the direction of electron displacement. This is a arrowhead in the middle of the covalent bonds in the direction of, and the arrow will be in the direction of more electronegative atom. Here is the chlorine is the more electronegative atom, so arrow will be pointed towards the more electronegative atoms in the middle of covalent bonds. Arrow will always be in the middle. Here is the middle arrow will always be in the middle towards pointing towards the more electronegative atoms. Here the C3 electron is shifted towards this side, more electronegative atoms, so it is denoted by this, always towards the more electronegative atoms. And carbon hydrogen bond is usually a standard for comparing the tendency of electron attraction repulsion. By we can get to know that inductive effect is positive inductive effect and negative inductive effect. Inductive effect is a two type: positive inductive effect, negative inductive effect. It is a negative inductive effect because it will attract the electrons, so this will show negative electron withdrawing group. This is called electron withdrawing groups and negative inductive effect groups. So this is a negative inductive group. Which group will be a positive inductive group? This will compare as a taking a standard of hydrogens. If C1 and hydrogen, and this will treat as a standard. This is a zero inductive effect. Hydrogen is assumed as a zero inductive effects. If chlorine comes in the place of hydrogens, it will attract more electrons, so it will call as a positive inductive effects. If it will be release electrons, if any group will come which will release electrons, then this is said to be positive inductive effect and positive inductive effect groups. It will compare positive negative inductive effects groups will compare as a standard taking the carbon hydrogen bond. Carbon hydrogen bond is usually a standard for comparing tendency of electron attraction repulsion group. Means chlorine is attracting electron, so which is more electronegative than hydrogen, so it is said to be that it is a negative inductive groups type. It will more the negative this point will be much more clear when we will learn about the type of inductive effect. We will learn there is a two type of inductive effect, positive and negative. We will learn one by one inductive effect.